Alrighty, hey guys. We are starting on our Unit 2 review this week. If you are looking for which activity I'm working on, we're working on Activity 5. It has the flash symbol on it. And so we're just going to go ahead and get started. So the very first thing you'll see on this page is some vocabulary, because when we start talking about functions, the vocabulary is super important. If you don't know what a function is, you can't tell me if something is a function. So let's just kind of quickly go over some of the vocab. The first thing we have is an ordered pair. That is an x and y coordinate. One number, comma, another number. And it tells you where on a graph you would put this piece of data. Second thing is a relation, and that's just showing how two sets of data are related, how your x is related to your y. And if something's a relation, you'll have a list of ordered pairs. It's how this x relates to this y. A mapping is basically just a visual representation of a relation. You can have all your x's in one bubble, all your y's in another bubble, and you just draw an arrow from each x to each y, showing that, hey, this x maps to this y. This x maps to that y. And then a function is a special kind of relation that shows each domain value has exactly one range value, or each input has only one output. If an input has multiple outputs, then it is not a function. And then we have an example of each. These are all relations, and I believe each of these relations, it's the same relation over and over again. So we have one relation that's a set of ordered pairs. We took that set of ordered pairs and wrote it as a table. We took that table, we wrote it as a map, and we took that map and graphed it. So these are all the same relation, it's just a different way of showing it each time. And if we look, this relation is a function. And that's because each input only has one output. It maps to each x only maps to one y. Each value in the domain only maps to one range. Okay, and I'm just using a bunch of different vocabulary so that we don't forget what any of these vocab words are. Okay, so let's go ahead and start on the guided practice. This number 1 asks us to express each relation as a table, a graph, and as a mapping diagram. So what we're going to do is we're just going to take this list of ordered pairs, put it in the table, graph it, and map it, just so we see those different ways of looking at relations. So we're going to take our ordered pairs and write them in the table. Put the x's in the x column and the y's in the y column. Okay, so we took this set of ordered pairs and made a table out of them. Then we're going to graph those. So we have a coordinate -5, 1, 2, 3, 4, 5, +3. So we went to the left 5 and up 3. We have a coordinate at -2, +1, so left 2, up 1. We have a coordinate at 1, -1, so that's right 1, down 1. And we have a coordinate at 4, -1, 2, 3. Okay. So here's all of here's our table. All of our points are graphed. Just so we know, oh wait, that is not -4, 3. I knew that was off. There we go. So if you look, a lot of people are going to be tempted to draw a line through this. We are not assuming that this is a function or that this is a linear relationship. We are just graphing the data. We don't have any evidence to suggest that what the coordinates in between these are. So we don't have anything to tell us that, so we're just going to leave it as a discrete graph. Okay, and then we're going to map it. And when we map it, we just recopy our coordinates, or recopy our x values, recopy our y values, and then we start matching them over. Okay, and then if these are in a different order, and these are in a different order, just make sure that you match them appropriately. Make sure like that the 4 and the -3 are matched and that the 1 and the -1 are matched. You don't want to like just do random arrows. You want to make sure that the input matches with the output. And just as a side note, this relation is, I cannot spell today, a function. This relation is a function, and that's because each input only has one output. Alright, oops, sorry guys. Alright, our second one, we're going to take this list of ordered pairs, make a table out of it, and something you should notice is that our x-coordinate is the same for each ordered pair. So what that means is when we go to graph it, we're going to have a point at 4, 0, at 4, 1, at 4, 3, and at 4, 4. So when we go to graph this, the input of 4 has 4 different outputs. So right off the bat, this is not a function. Something that is very helpful is the vertical line test. If I were to draw a vertical line on this graph, and I could draw it anywhere, and I usually use a pencil in class, so if I were to take a vertical line, it should only ever touch one point of my relation. If it only touches one point, it is a function. If it touches multiple points, like here, if I had a vertical line here, it would touch 4 different points. So it fails the vertical line test. So it's not a function. And I abbreviate as VLT because I usually am too lazy to write out the whole 3 words. But, you know, same thing. Okay, so when we do our mapping, you could write out all 4 fours, but that really, it doesn't, you could write out all 4 fours, but A, that is time consuming and unnecessary, and B, it's a lot easier to see that this one input has multiple outputs if you only write it one time. So typically if I have a value that you see more than once, I only write it once and draw 2 arrows. And that's a lot easier to see. Like when you look at this one input has 4 different outputs, so we know it's not a function. So if you have if you're making a map, and you have more than one of a number in your input or more than one of them in an output, just write it one time and have either multiple arrows coming from it or multiple arrows going to it if it's in the output. Just makes it a little bit easier to see whether or not it's a function. Okay. I forgot that I printed this on 2 separate sheets. Okay, so next section, we are just determining whether or not these relations are functions. So, and then we're going to explain why or why not it's a function, and then list the domain and range. Okay, so this first one, this is a list of ordered pairs. I'm going to check the inputs. So I have an 8, a -4, a -6, and a 1. So since I don't have any repeating inputs, there's no, I can't say that, or since I don't have a repeating input, I know that each input has only one output. If I had like 8, 2, and then I had another 8, I would have to see if it was 8, 2 again, or if it was 8, 7, or something other than 2. But the easiest way to check is, do I have repeating inputs? Nope, so it's a function. So yes, this is a function. And my explanation, each input, I can't spell today, I am so sorry, has only one output. Okay, so domain and range. Your domain is every possible input, every possible x value. And your range is every possible y value or every possible output. So we're going to look at our relations and determine the domain and range. If you have something that is a list or a discrete graph or a graph that doesn't have arrows, actually, you know what, let's not even worry about that. If it's a discrete set of data and you just have a list of numbers, then we're just going to list the x's for the domain and list the y's for the range. This only works if your data is a list and you don't have any other, like, it's not a list of a function or something. We'll get into that in a minute. But basically here, I just have 4 pieces of data, so I should have 4 numbers in the domain. Alright, and then as far as my range goes, I have 2, 1, 2, and 9. So that's my y coordinates. And if you notice, I have 2 copies of the number 2. I only have to write the 2 once. You don't have to write it multiple times. So these are the values in the domain. These are the values in the range. I'm going to alternate colors here because it's not lined or anything, and I'm worried about it like bleeding all over the place. Okay, so number 4. My inputs are 1, 4, and 8. I don't have any repeating inputs, so it's automatically a function. So a lot of people are going to say, wait a minute, you have 1 twice in the output. So a friend of mine likes to call these the cheating x's. You don't want your x's to cheat. Your x's can only have 1 output. They can only match to 1 y. Now there's a double standard for y. Y can have as many x's as they want. I don't know. It's a double standard. You know, y's a little promiscuous. So our y's we can have 2 of the same thing in the y column. You just don't want 2 of the same thing in the x column unless it matches with the same y. So each input has only 1 output. Now those inputs might have the same output, but each input has only 1 output. So each input has only 1 output. Okay. Our domain, we're going to look at our x values. We have 1, 4, and 8. Our range, we have 1, 4, and 1. So I'm not going to list 1 twice. I'm just going to do 1 and 4. Okay. Alright, number 5. So we have a mapping here. So let's see if this is a relation. I'm sorry, a function. It is a relation. We're just going to see if that relation is a function. So 4 has 1 output of -3. 3 has 1 output of -5. But 2 is mapped to 2 different outputs. So since 2 has 2 different outputs, it's mapped to -4 and -5. This one is not a function. So we're going to say the input 2 has 2 different outputs. Alright, so even though it's not a function, we can still talk about the domain and range. Here we're going to list all 3 elements in our map. So we have 4, 3, and 2 as our domain, and our range is -5, -4, -3. Okay, so then we get to this fun star-shaped graph. Okay, so is it a function? Let's do the vertical line test. If it passes through more than 1 point at a time, then it's not a function. So I could draw my vertical line here and say, look, it only touches the function once. But if you draw your vertical line here, that's not a very pretty vertical line, but you get the idea. It's going to touch the function twice. So this is not a function because it touches it more than once. And to the side, we can just say it fails the vertical line test. And there are multiple inputs that have 2 outputs. And some of them that I think have 3. Like if you go here, yeah, that one has 3. So there's multiple inputs that have multiple different outputs. All right, so let's talk about our domain and range here. So these top ones were easy because you just listed them. Well, this one isn't a list. This is an actual graph. So we need to talk about all the possible x values and all the possible y values. So I'm going to look at this graph. And what I'm going to do is I'm going to take some sticky notes to help me with this. Okay, so I think we can all agree that if I were to zoom out on this graph and to look at more of the actual coordinate plane, there'd be nothing to the left of this, and there would be nothing to the right of this. It's not one of those things where I zoom out and you keep seeing more and more and more. So what we're going to do is we're going to cover up from the smallest point on this graph and cover up to the largest point on this graph. And when I say largest and smallest, we're talking about the smallest x value to the largest x value. So my graph, there's a point everywhere from this point to this point. So we're going to look at our lowest and our highest values. So this point on the graph is at -8. And this point on the graph is at about 4. It's kind of hard to tell, but we're going to say 4. So my graph goes from -8 to 4. And there's no breaks in between. Like, I have a point at every single x value between -8 and +4. So how we're going to write this is I'm going to say that so we use brackets, and we're going to say that my values of x include everything from -8 all the way up to +4. Okay, so we start at -8 and we end at +4. X can be any of the numbers in between those two numbers. So, there we go. All right, and let's talk about range. We're going to set our range up the same way. Range is our y values. It's every possible y value. So again, I think you'd agree that if I were to zoom out, you wouldn't see anything above this, and you wouldn't see anything below this. There wouldn't be any more graph than what we have. So I'm going to cover up to the top point. Okay, and I'm going to cover up to the bottom point. Okay, so again, there'd be from the for the range, there's nothing above or below this graph. So let's look at what our lowest range value is up to the highest range value. And again, if I were to graph it, I have a point at every single point from here all the way up to here. So there's not a y value that I skip or anything. Okay, so the smallest y I have a point for, or the smallest y I have that my function touches, is -5. And if you look closely, I don't think it actually touches -5. I think it's like right above it. So it's kind of hard to tell. So what I'm going to say is, since it doesn't actually touch -5, but it's like really close to it, I'm not going to use an equal to bar. I'm going to just say it's greater than -5. So y is greater than -5, or -5 is less than y, and this goes all the way up to +6. Okay, so y is between -5 and +6. So there's a point for everything between -5 and +6. Okay. So there's our domain and range. Again, we're measuring everything in between the highest and lowest points on the graph. So the highest and lowest x and the highest and lowest y. Alright, so let's move on to 7. Is this a function? So the first thing I notice is that in my x's, I have 2 6's. And they each have a different output. So no, this is not a function. The input 6 has 2 different outputs. Okay, again, this is a table. It's not really it's not like it's a equation or anything, so we can just list our domain and range here. We have 5, 6, and 7 in the domain. Even though I have 6 twice, I don't need to write it twice. And then our range is 1, 2, 3, and 4. Alright, and we're done. Okay, number 8 is pretty much the exact same thing as number 7, just with different numbers on top. Again, we have 2 -3s. They match with 2 different outputs. So no, this is not a function. The input -3 has 2 different outputs. Our domain and range is a list again. And boom. Alright, number 9 is another graph. So this one's different from the star because it's got the arrows on it. So if I were to zoom out, let's talk about, actually, let's stop for a second. Let's answer the first 2 questions before I jump into domain and range. So is this a function? Well, if I were to graph my vertical lines, it's only ever going to touch the function at once at any given spot. Even if this were to continue, it's only going to touch it once. So, excuse me. Yes, this is a function. And we know that because it passes the vertical line test. Okay, so now let's talk about domain and range. So the domain and range is different from the star graph because it has the arrow, so it's going to keep going. If I were to zoom out, and we're talking about from left to right, let's only focus on left to right. If I were to zoom out and look at this function, it's going to keep going to the right. It's going to keep going to the left. So think about left to right. It's going to keep spreading out. You're not going to randomly see it stop. You're not going to see it go, and then, it's going to follow the same pattern. So yeah, so you're not going to see it stop or anything. So this function is going to continue, and it's going to go all the way to the left till it hits negative infinity, and go all the way to the right till it hits positive infinity, and it's not going to skip anything. So every single x value that there ever has been and ever will be is a possible domain value for this function. So there's not a number, if you throw a number out there, it will be in the domain of that function. So what this is telling me is that my domain, or my values of x, are all real numbers. Okay, so I'm going to do range underneath. I'm going to just take up both. So my domain is all real, x is all real numbers. There's not an x value that is not going to be in the domain. So let's think about the range. If I were to keep zooming out and looking at this graph, this is going to continue to go up, and it's going to continue to go down. It's going to go all the way up to positive infinity, go all the way down to negative infinity. It's not going to just randomly stop somewhere. So again, every single possible y value will be in the range. There's not a y value that I'm going to skip. There's not a y value that is just for some reason not going to be in the range. So, again, my y, or my range, is that my y values can be all real numbers. Alright. Okay, so let's talk about 10. We've got a mapping. And if I look, 4 maps to 5, 8 maps to 5, 12 maps to 10, 16 maps to 15. So all of my inputs only map to one output. So yes, this is a function. So again, even though 5, it's a y, it can have 2 inputs. It's a little unfair, but, again, we don't want our x's to cheat, but, y's feel free. Okay, so Each input has only one output. Okay, our domain, again, since it's just a mapping, it's not a graph, it's not a function, we're just going to talk about these two bubbles that we have. So my domain is 4, 8, 12, and 16. It's everything in that first bubble. My range is 5, 10, and 15. All right. Let's move on to the last 4 questions. So this says, when using function notation, evaluate each function for the given domain. So just a quick recap on what function notation is. It's a way for us to name our functions so that if we've got more than one listed at a time, we don't get them mixed up. So we have function f, function g, function h, and function k. And that way, I always tell my kids, like, if all of you were named Jerry and I asked Jerry to go up and work this problem on the board, you have no idea who I'm talking about because you all have the same name. So we're giving each of these functions a different name, so we can easily, if we have like 6 functions on the board that we have to do some work on, I can say, okay, I need you to work on function F. I need Billy to work on function K. I need Marie to work on function G. So that's what function notation is. It is not F times X or G times X. It's just a name. This is actually your output for your function. X is your input. And what this is saying is if I input a value in for X, I can write it here and say, what's the function when X is 2? What's the function when X is negative 8? And that's one of the good things about function notation as well. Okay, so when we evaluate these, all we're going to do is take our domain values and put them in for X. Again, domain is all your possible X's. So they gave us 3 specific values in the domain and asked us to figure out their output or the range values. So that's what we're going to do. We're going to plug negative 2 in for X. Okay. And what this is asking is, what is the function when X is negative 2? So we're going to multiply. Negative 3 times negative 2 is positive 6. Positive 6 plus 1 is 7. So I can write out here, f of negative 2 equals 7. Okay, we'll do the same thing for f of 0. Okay, negative 3 times 0 is 0, plus 1 is 1. So f of 0 is 1. We'll plug in 2. Negative 3 times 2 is negative 6. Negative 6 plus 1 is negative 5. So f of 2 is negative 5. Okay. All right, let's move on to 12. Same concept. And it's the same values too. We're just, it's just a new function. So, g of negative 2, we're going to do half of negative 2 minus 5. Half of 0 minus 5. And half of 2 minus 5. Okay. So half of negative 2 is negative 1. Negative 1 minus 5 is negative 6. So g of negative 2 equals negative 6. Half of 0 is 0. 0 minus 5 is 5. Okay, half of 2 is 1. 1 minus 5 is 4. I'm sorry, 1 minus 5 is negative 4. Oh, and this is negative 5. Yeah, 0 minus 5 is negative 5. I just didn't write it. Okay. Alright, h of x is x squared. Real quick, I would always, when inputting a number in for x, use parentheses. And if you have a graphing calculator and you want to square something, I can't. You're scared. Hold on. It's okay, baby. You want to sit with Mama? Yeah. Okay. I'll color. You can color in just a minute. Okay. So, when you are squaring something, if you're in the graphing calculator, you want to use parentheses, because if you don't, I'm going to do this on sticky real quick. If you do -2 squared in the calculator, it's going to take 2 and square it, which is 4, and then make it negative. If you do -2 squared, -2 times -2 is +4. So you have to be really careful. Use those parentheses in the calculator. Okay, so -2 squared is +4. H of 0 equals 0 squared. 0 squared is 0. H of 2 is 2 squared. And that, again, equals 4. So this is another one. Each input has only one output, but I've repeated my outputs. And that's okay. It's still a function, because the only thing I get when I plug in -2 is 4. The only thing I get when I plug in 2 is 4. So they each only have one output. All right. And sorry about that interruption earlier. I am, you know, with us being out on quarantine, we've got our little one at home too. So, you know, if you hear 2-year-old noises, just don't worry about it. Okay, so this one's a little interesting because our x value, our input, is also our exponent. So we are inputting an exponent. So we can deal with it, but it's just a little bit interesting. Okay, so 2 to the -2. So this one's fun. When we do 2 to, if you do this in the calculator, you're going to get a decimal. However, if you're in year-long algebra, we've already done exponent rules. If you are in semester-long algebra, you may have just gotten to this, or we're just about to get to this. So what we're going to do is a negative exponent is equal to the reciprocal of the positive exponent. I know that seems weird, but that's one of our exponent rules. So in order to make this exponent positive, you flip it. And so you have 1 over 2 squared. And we know that 2 squared is 4, so 2 to the -2 is going to be 1/4 instead of 4. A lot of people are going to be tempted to do -4, but 2 to the -2 is 1/4. Okay, 2 to the 0. Anything to the 0th power is 1, and then 2 to the 2nd is 4. So we have 1/4, 1, and 4. Okay. And that is your entire guided practice. So yeah, I know this is kind of a lengthy video, but I hope it was helpful and hope that you got some good information from this. So y'all stay safe, and I will have another video for y'all soon. Bye.